Let's go over notes for section 9.1 on sequences. So sequence is simply defined as a function whose domain is the set of positive integers, natural numbers greater than or equal to 1. Although a sequence is a function, it is common to represent sequences by subscript notation. For instance, the first, second, third, fourth, and fifth term will be represented by a sub 1, a sub 2, a sub 3, so on and so forth until a sub n. And this is simply a representation of a sequence. The first term is mapped onto a sub 1, second is mapped onto a sub 2, so on and so forth. And these numbers, a sub 1, a sub 2, a sub 3, all the way to a sub n, are the terms of the sequence. And the number a sub n is called the nth term of a sequence, and the entire sequence is has this notation with a bracket for a sub n with the braces. A sequence can be expressed by either a number of terms in the sequence separated by commas. For instance, here in this example, 4 fifths, 8 sevenths, 12 ninths, all separated by commas. Or it can be expressed as an explicit function defined by the rule of sequence. For instance, what we have here, 4n over 3 plus 2n. Or can be represented by a rule of sequence that is set off in braces, like similar to what we just saw with the second example. Okay, so let's move on to some examples here. If a sub n is equal to this rule of sequence, 4n over 3 plus 2n, list out the first five terms, then estimate the limit as n approaches infinity for a sub n. So if we list out the first five terms, we simply plug in our n value into our rule of sequence, and we go through and find each of the first five terms. So if I want to find the first term, I just plug 1 in for n. So this gives me 4 over 3 plus 2, which is 4 fifths. If I want to find the second term, I simply replace n with 2, and I get 8 over 3 plus 4, which is 7. And then this moves on to the third term, fourth term, and fifth term. And so what happens then to the terms as we go to infinity? What we can do is we can find the limit as n approaches infinity for our rule of sequence. And if we do that, we know that looking back at an old rule that we've been exposed to, which is simply that if the degrees are the same between numerator and denominator, and we're finding the limit as n approaches infinity, we can simply take the ratio of the leading coefficients. In this case, we have 4 over 2, and that gives us 2, so our limit as n approaches infinity is equal to 2. Okay. So some notes here. Let a sub n be a sequence of real numbers. So if the limit of a sub n as n approaches infinity is equal to positive infinity, then we say that our sequence diverges to infinity. Okay. And if its limit goes to negative infinity, then we say that our sequence diverges to negative infinity. So basically, as this sequence, as we follow the values of the sequence, we see that the value does not come together to a finite number, but it just keeps increasing to infinity. So we say those are divergent sequences. However, if the limits of a sub n as n approaches infinity is equal to c, meaning that it's a finite real number, so think of this as a limit where our value keeps getting closer and closer towards a specific real number, then we say that our sequence converges to that finite number, to c. Okay. If the limit as n approaches infinity for a sub n oscillates between two fixed numbers, then our sequence diverges by oscillation. Okay. So the scenario that we're most interested in is the third scenario, where we're trying to, it's most interesting if we're able to determine if a sequence converges, because those are going to be most of the problems that we're going to be trying to find. We're trying to determine whether a sequence is converges or not, and that information will allow to help us later on as we deal with series. Okay. A couple of notes here. N factorial, okay, is represented by this notation here. It is defined recursively as n times n minus 1 factorial, or n times n minus 1 times n minus 2 times n minus 3. So basically, the factorial is simply finding the product of all positive integers less than including that n value. So in this case, 5 factorial is simply 5 times 4 times 3 times 2 times 1, all the way until 1. Okay, the primary focus of this chapter concerns with sequences whose term approaches a limiting value, and we're concerned most about these types of sequences, which are called convergent sequences, or sequences that converge.